So this is an example AP problem involving slope fields. It says shown above is slope fields for which of the following differential equations, and we're given 5 options here. So we need to match this slope field to one of these equations down here. Now we could just go through and plug in some values into each one of these and see if it matches up, but I think that won't be as time efficient, so let's try to be strategic about this and notice some things about this slope field. So first of all, I can see that along the x-axis we have a slope of 0 each time we're flat. So I know that the slope dy dt is 0 when y equals 0 along the x-axis there. Also, it looks like we're going to be flat whenever x equals -1 right here, because this would be 1, 2, 3, 4, 5, -1. So the slope is also 0 when x equals -1. So we're going to use that information to narrow our options here. What I'm noticing is that these slopes are going to be 0 at those points. We can kind of think as these of these kind of points as roots then, and individually they're going to make the whole equation 0, and together that will also be 0. So I'm thinking then that a product of these two of roots involving these kind of would make the equation work. So what plus x would make y? If I plugged in -1, it would be 0. Well, x plus 1, because then you plug in -1 and that will be 0, and we can multiply that with y. So if I plug these in here, that would make this 0 certainly. So this would expand out then to be xy plus y, which is one of our choices. So let's see if other points on this slope field correspond with this equation as well. So I'm going to try 1, 1 and see if that would work. So if I plug in 1 for x and y, I would get 1 plus 1, 2, and that does indeed look like a slope of 2. So that's good. And I'm going to try another point. Let's try -2, -1. So if I plugged in -2 for x and -1, I would get -2 times -1 minus 1. So it would be 2 minus 1, which would be 1. That does look like a slope of 1. So it looks like this would work, and C is our answer.